Okay, so now we're going to try and use those fundamental trig functions to do some simplifying type problems. Okay, so we've got a series of problems on the board behind me, and our instructions are to write the following expressions as a single trig function or power of a trig function. So we're going to work our way through trying to make that happen. Okay, so let's look at the first one. The first one we're going to look at is sine squared theta times cosecant squared theta minus 1. Now, there's a couple of good big tools in our tool belt when we're doing this. One is we can try and rewrite everything in terms of sines and cosines and look at what canceling we get. Another, especially when I have squared factors running around, is to think about how I might be able to apply Pythagorean identities to this. So because I've got a bunch of squareds in this problem, I have sine squared and I have cosecant squared minus 1, I'm going to think about using our Pythagorean identities. So here's kind of our short sheet of our different identities. And so let's look at our Pythagorean identities. Now I've got a sine squared in the problem, okay? But one of our big tools, remember I said earlier, was to rewrite these as sines and cosines. Since that's already a sine, I'm going to start by not messing with that one. I'm going to look and see if we can simplify that cosecant squared minus 1. Well, the Pythagorean identity that we have is 1 plus cotangent squared equals cosecant squared. But notice that if I just subtract 1 from both sides of this identity, right? I subtract 1, that changes this to say cotangent squared equals cosecant squared minus 1, okay? So let's try replacing cosecant squared minus 1 with cotangent squared, okay? All right. So first thing we're going to do is we're just going to leave the sine squared and replace cosecant squared theta minus 1 with cotangent squared. Okay, so now it's looking better, a little bit better. We don't have this 1 running around. We just have trig functions. That tends to make our life a little easier. So now let's try another big toolbox, the one that I've now mentioned. This will be the third time, and that's rewriting everything as sines and cosines. Now this is already a sine. So cotangent, remember, is cosine over sine, which means that cotangent squared is going to be cosine squared theta over sine squared theta. So that's our cotangent. We're going to leave our sine squared alone. If it helps, you may think of sine squared as sine squared over 1. And now we're going to look for cancellation. Notice that I've got sine squared on top and sine squared on the bottom. Those cancel, leaving me with just cosine squared theta. Okay? And that meets what we needed here, a single trig function or a power of a trig function. This is a power of a trig function. Okay? Now let's look at our next one. Our next one is secant of x over tangent of x. Okay? Now, I don't see any squares in here, so I'm not going to use the Pythagorean identity. Instead, let's try to rewrite this completely again as sines and cosines. Okay? So take a minute and think, what is secant in terms of sines and cosines? Well, secant, using a reciprocal identity, is 1 over cosine. And now think about tangent. What's tangent in terms of sines and cosines? Well, tangent is sine over cosine. Now, it may seem like we made this worse. Before I just had a single term over a single term, now I have a fraction over a fraction. But let's rewrite this and see if we can do any cancellation. So 1 over cosine divided by sine over cosine. Well, that is really 1 over cosine divided by sine over cosine. Right? These say the same thing. The division bar and the division symbol are the same thing. And now, if I remember my rules for dividing fractions is the same thing as multiplying by the reciprocal. So this sine over cosine becomes cosine over sine. And now we can finally see the cancellation. Cosines cancel, and that leaves me with 1 over sine. Okay. Now we're still not where we need to be because this says a single trig function or power of a trig function. Implicit in there is we want our trig functions in the numerator, not the denominators. In other words, we don't want any denominators. But think of a reciprocal identity. What is 1 over sine? Well, using a reciprocal identity, 1 over sine is the same thing as cosecant. So there's our final answer. Secant over tangent is the same thing as cosecant. Okay. All right, let's look at that last one. Last one, tangent squared of x minus secant squared of x. Now there are several ways to approach this one. Okay, now first, when I look at this, I think, well, it sort of looks like a reciprocal identity, or no, Pythagorean identity, because it has the squareds in there, right? So we could try to tackle this by thinking of it as a Pythagorean identity. You also could try and tackle this using sines and cosines. Both will eventually work, and both will eventually get you to the same place. For fun, let's do it both ways, okay? And show that we're going to get to the same place either way. I'm probably going to run out of room, but that's okay. Let's do this first by using Pythagorean identity. Okay. So let's pull up our Pythagorean identities real quick. So I'm going to share our identity cheat sheet. Okay, so when I share my identity cheat sheet, I'm looking for a Pythagorean identity that involves tangent and secant. Okay. Well, that's this guy here. And notice that we almost have what we want. So one thing we could do is we could just use algebraic manipulation and try and get this to look like tangent squared minus secant squared. Most people actually have more trouble with that than you might think. Okay? So instead, maybe we can just do some substitution here. Notice that secant squared is equal to tangent squared plus 1. So let's look and see what happens when we just do that substitution. Replace secant squared with tangent squared plus 1. Okay? So I'm going to replace our secant squared with tangent squared plus 1. So I've got this tangent squared minus, I'm replacing secant squared with tangent squared plus 1. And now let's see what happens. When I distribute the negative, I'll have tangent squared minus tangent squared minus 1, distributing that negative. Tangent squareds cancel, and I'm just left with minus 1. So this reduces down to -1. That's probably the easiest route to do, but let's go ahead and try this a different way. Let's try and simplify this by replacing everything with sines and cosines. Okay. All right, so I want to take tangent squared minus secant squared, and I want to see if I can replace everything with sines and cosines. All right, tangent is sine over cosine, which means tangent squared is sine squared over cosine squared. Secant is 1 over cosine, which means secant squared is 1 over cosine squared. Oh, now this actually looks pretty nice because notice that right now I have a common denominator, right? I have a common denominator of cosine squared, which means I can combine these fractions. So when I have a common denominator, I'm going to add or subtract my numerators, in this case subtract sine squared minus 1. Okay. All right, well, did we gain anything? Well, now the top looks like a Pythagorean identity, or part of a Pythagorean identity. Sine squared of x minus 1. Sine squared, what's the Pythagorean identity involving sine squared? Well, it says sine squared of x plus cosine squared of x equals 1. We have sine squared of x minus 1. So I'm going to do a little algebraic manipulation. If I subtract 1 from both sides of this, I'm going to have sine squared of x plus cosine squared of x minus 1 equals 0. And I'm going to move my cosine over. So I'm going to subtract cosine squared of x from both sides. That gives me sine squared of x. Cosine squared canceled. Minus 1 equals negative cosine squared of x. Now I can replace this sine squared of x minus 1 with negative cosine squared of x. So sine squared of x minus 1 over cosine squared of x becomes negative cosine squared of x over cosine squared of x. Cosine squared over cosine squared cancels, and I'm just left with -1. Same thing we got over there. There's often more than one way to approach these kind of reducing problems where you're trying to simplify, okay? Sometimes one way is simpler than the other. I think this way might have been a little simpler, but it doesn't mean either way is wrong. Do the one that kind of makes the most sense to you. All right.